Hello, everyone. My name is graur. I'm a second-year PhD student at ETH Zurich, and I'm presenting work that is done together with aymon, which is a first-year PhD student at ETH Zurich as well. Our project is Cashew, machine learning input data processing as a service. Okay, so let's begin by actually taking a look at what a traditional ML workload looks like. Usually it consists of two parts, the input pipeline and the model that is being trained. The input pipeline fetches data from a storage layer, it applies some ETL on it, and then it submits it to the model that is being trained. The input pipeline runs on CPU generally, whereas the model actually runs on an accelerator, but usually both of these processes actually run on the same machine. Now, the input pipeline can have many shapes and forms. An example from computer vision is that you're reading a binary file, you're deserializing it, applying some random transformations such as flips, rotations, or translation, and then going back to this process a number of times until you obtain a batch. The batch is then submitted to the model who trains on it, and once it's done with that, it requests some new data from the input pipeline. Now we're focusing on the input pipeline because it can occupy up to 60% end-to-end training time, which is very significant. It is a source of I/O and computational stalls, meaning that the accelerator ultimately will idle. But this is both expensive and inefficient for the user. And finally, it presents a lot of opportunity for computational reuse. Studies show that just a small part of the unique input pipelines account for the majority of computation that input pipelines require in the context of a big organization. Our proposed solution for this issue is Cashew. Cashew consists of a set of dynamically allocated workers and a dispatcher which liaises between the clients and the workers. We also augment the storage layer with the cache. Now, how does this work? Well, a client has a model to train and it requests that its input pipeline be processed by Cashew. The dispatcher analyzes the input pipeline, and then it understands how many workers this processing would initially require. It recruits those workers, and those workers get in touch with the storage layer, who then retrieve the data. If the data is already cached, then all the better. They don't need to compute anything, they just need to relay the data to the client. Otherwise, they compute it, and then they send it back to the client. The client will start to communicate with the workers, asking for new batches as it progresses to the training process. And ultimately, since this is a long-running service, more and more clients join, more and more workers are recruited. Now, in the ecosystem of machine learning systems, Cashew distinguishes itself because it supports multi-tenancy, it disaggregates input and model computation, allowing these to independently scale. It also employs automatic elasticity, adding and removing workers based on the demands of the client. And it also exploits caching at the both intra and cross-job level. Cashew presents some interesting challenges as well, some of which are presented here. So what to cache, what not to cache, how to deal with random operations, whether to cache the entire input pipeline or just parts of the input pipeline computation, how to efficiently assign resources such that you balance performance and cost, and how to ensure that data is maintained private and only accessible to those who are intended to access it. Okay, thank you very much. This has been a brief introduction to Cashew, and here are our references for this talk. Thank you again.